All right, everybody. So this will be part 2 of our series on tangent lines. You'll see in this video problems that involve having a curve and a tangent line and then some situation beyond that. Okay. So let's just, I think the examples speak for themselves. I don't really have anything to explain on the front end of this. So I just want to show you my first example and give you some time to think about it. Pause the video if you need to. And then I'll show you visually what I think is happening in that problem. That may help you understand the situation a little bit better. When you take the test, you might draw a sketch to go along with things if it helps you keep track of the information better. And then after that, I'll talk about the solution. So first example I want to show you, say you have a curve, f of x is x to the third power minus 5, okay? And the tangent line to the curve at the point where x is 1.8. So say you have those two things, okay? The curve and the tangent line at a particular spot. Can you find the x-intercept of that tangent line? Now, based on part 1, we can find the equation of the tangent line. All right, there was a procedure that I gave you for doing that. So this is just one step beyond that to find the x-intercept of that tangent line, okay? So, all right, let's look at the picture like I said. So it may give you a little bit more to think about if I showed you visually what we have here. So this curve is x to the third power minus 5, all right? And that's the curve mentioned up there. There's that point where x is 1.8. Notice I put the y-coordinate on the picture. The y-coordinate wasn't given, right? It just said the point is x is 1.8. But we do know it, so I went ahead and included it. Why do I say we know that? Well, the curve is x to the third power minus 5. Y is x to the third power minus 5. So if you know the x, you can find the y through that equation. So that's the coordinates of that point, 1.8 and 0.832, okay? And this is the point that I'm looking for. The tangent line is there in red. I'm looking for the x-intercept of it. All right, so just wrap your head around that situation. Maybe you even think of it. You can try to work it if you want to and pause the video and see what answer I come up with here in a minute. However you want to do it, but I'll let you decide on that and also show you the solution right now. Okay. So here's the solution. First step is to think about, well, so what's the slope of the tangent line? If I ultimately need the equation of the tangent line, and what's that going to look like? The tangent line, what kind of geometric object is that? The tangent line is a line. And such things have equations that take the general form y equals mx plus b. So if I need that equation ultimately, then here's what it looks like. And the information needed are these numbers m and b. M is the slope of the line, or in this case, the tangent line. And b is the y-intercept. Okay, so, well, I can find the slope first. That is found through y prime for reasons explained in some of the other videos. For y being x to the third power minus 5, you'll find y prime to be 3x squared. Now, I wasn't going to go through the whole derivation of that, but it's covered in other videos. And we could say, well, y prime would be, what was that? Try and think, just like quiz yourself for a moment. What did we learn through the limit process of how to find y prime? Wasn't it that? That was it. That's the limit definition of how to find y prime. There's a procedure and a formula on its own for doing that. That was covered in other videos. And all I'm saying is if f of x is x to the third minus 5, then going through all that, okay, you'll get 3x squared. Okay, so I want to establish that first. On the test, not on the quiz, but on the test, I might just go ahead and give you y prime for some of the questions. You know, okay, so for some of the ones that involve a few steps beyond finding y prime, maybe I'll just give you that. So for now, let me just tell you that's what it is, okay? So next thing, the slope on the curve at that point that we were given is, well, okay, you put the x coordinate of the point you're interested in there, and you do the math at 9.72. And if we get that, we get a partial equation of the tangent line. Remember, there's the what's called the slope-intercept form. Y equals mx plus b. I've found so far that the slope is 9.72. So I put that information in. And as a partial equation for the tangent line, it must be y equals 9.72x plus some number b. B is the y-intercept. It's hard to find that number by, say, figuring out where this line hits the y-axis. So what we do is we find b by a known point on that line. So do we know a point on the tangent line? Well, look, if the picture helps you remember all this, look at the picture. See the tangent line there in red? We're trying to find the equation of that right now. And it does hit this point. You know, that point right there is the one point that's common to the curve and the tangent line. So I know that if x is 1.8 on the tangent line, then y has to be 0.832. So I could use that point. So look what I did. I took this, I put in the known x and y coordinates for that point, and that gives me enough information to solve for b. Okay, so there's b. Now I've got my equation of the tangent line. That tangent line, you see this thing there with red ink on my picture where my question is stated, that's going to be y is 9.72x minus 16.664. All right. The rest of it's not so hard. I think I'll mention, though, that, you know, about this tangent line, it's pretty steep. If I find the slope to be 9.72, that's like a 10-to-1 rise over run. Almost 10-to-1. If I say the slope is 9.7, that's like 1 to the right and 10 up from point to point. Okay? Now, all right. What is the x-intercept of it? Our original question said, find the x-intercept of the tangent line. There's its equation. To find the x-intercept of any curve, well, what's true about the x-axis is that y is 0. So if you want to know where it hits the x-axis, you put 0 for y, you solve for x, and we'll get 1.7144 with a little bit of rounding. Okay? All right, so that point right here, just locate that point. All right, it's about 1.7144. Okay. Now, I developed this question from something called Newton's method. All right. So now that I have my answer, there it is. I want to tell you a little bit about its relevance to something called Newton's method. So notice that this curve's right there. What's its x-intercept? Where's that point? Where does the curve x to the third power minus 5 hit the x-axis? That would be the third root of 5. Computing the third root of 5 is sort of a complicated thing to do. All right. So Newton's method was something that computers once used to estimate higher order roots, for example. And notice this, I'll calculate the third root of 5 with my calculator, and I find it to be 1.709, okay? Doesn't it make sense that if this point is given to be close to that one, if I can find the x-intercept of that tangent line, that will be pretty close to whatever the third root of 5 is. And sure enough, I found that to be 1.714, and in fact, the third root of 5 is 1.71. All right, I got it correct to 1 part in 100. Now, so the value in a computer doing this process is it can iterate this several times, like find the tangent line, find the x-intercept, jump from a new point, find that tangent line, find the new x-intercept, jump from that point. And if, say, a computer was to recreate that process several times, it could get like an extreme precision on that number. All right. Now, I think that's a little too much to make a whole video about, but if you're interested, see Newton's method for a little bit more information on what I just said. Okay, let's look at another example. So, all right, this one is given almost entirely in terms of a picture. Okay, there's not much to read besides it saying find the y-coordinate or the x-coordinate. Perhaps you'll see some question on the quiz that says find the location of this or that point on the picture. All right, so that's kind of what this one aims to be like. So let's find the y-coordinate of the unknown point in the picture below. So I see a curve. Okay, all right, that's a curve. Its equation is y is negative x squared plus 6x. I see an unknown point and a tangent line at that unknown point. All right, I see that the tangent line happens to go through this, distant point, 1 for x, 21 for y. I guess I don't want there to be any confusion about what that thing in red is, so I'll go out of my way to say it. That is the tangent line, and the tangent line in red is the tangent line to the curve at the unknown point. All right, so that unknown point is the point that the curve and the tangent line have in common. It's the one point that's on both of them. All right, so can you tell me where this point is? That's what it says. Tell me where, whoops, this point is. Give me its y coordinate to be specific. Okay, now it's like every problem that we do in math, we need some kind of premise to work with, or some kind of starting point that we develop into the answer. So no different with this one. I need to start somewhere. And that's probably the hardest part about this one, is figuring out how you start if nobody's ever told you. All right, so here's what I'll give you for this. Say that the premise we can work with is at the point xy, and let's call our unknown point that. Since we don't know what it is, we'll say, well, it's got an x coordinate and it's got a y coordinate. All right, okay, so at that unknown point, x and y, the slope of the curve being y prime is what the slope of the curve is equal to the slope of the tangent line. Okay, now just in general, that's true. The slope of the curve is the same thing as the slope of the tangent line. Way back when, I would have illustrated that on an earlier video by saying something like, do the tangent line and the curve look like two different things? Yeah, of course they look like two different things. But what about when I zoom in at that point? Now they look like the same thing. You really can't tell the difference between them. Right there, as this line in red and that curve in pencil have blended completely together, all right, you can't tell them apart. They're the same. The slope of the curve is the slope of that little piece right there, which goes about like this in that direction. And that's also the slope of that tangent line. Okay, so that's the premise that we'll be working under for this one. Okay, we'll find the slope of the curve by y prime, the derivative, and we'll find the slope of the tangent line. Well, how do you find the slope of a line? You find the rise over the run between two known points. Okay, so in other words, if like right here I see, well, there's the tangent line, it's in red ink, and this is the rise and this is the run, right? I mean, that's the basic idea, rise over run. And you got this point and that point. And so you can do rise over run with the formula that we all learn in algebra. Okay, so here's where we can take that. Y prime, the derivative of negative x squared plus 6x is negative 2x plus 6. Okay? Then the slope of that tangent line from the rise over run formula from algebra is going to be y minus 21 over x minus 1. I can do y minus 21 over x minus 1. Okay? Now, you may have learned that. Let me see. How did you learn that now? What did the formula look like when you learned rise over run in algebra? Okay, did it look like that? Yeah, that's all I'm thinking about and all I'm using when I did this. Now, from here, we need to take it a little bit further, and where we're stuck with this one is I have an equation with two variables. It's got x and it's got y. And in order to solve a single equation, I needed to have one variable, only one variable. So I've got to put y in terms of x or x in terms of y. One of those, okay? The way I'll do it is I'll put y in terms of x. You know, that point right there, it is on the curve, isn't it? Right? See, I drew it. It's on the curve. It's right there. So what is y on the curve? Well, on the curve, y is negative x squared plus 6x. So notice in my next step, I just substitute for y, negative x squared plus 6x. All right, in my next step, I multiply both sides by x minus 1, okay? Then I multiplied these together by FOIL multiplication. I moved all my terms to the right-hand side, which gives me this, and that's just algebra. I'll let you try to fill in the steps there. If you get stuck with it or you can't do it, let me know. And then to solve it, I factored it, and I got x is 5 or x is negative 3. So which of these is our answer? Are they both the answer? Is one or the other the answer? How do we make sense of these two numbers? Well, so they are x coordinates, right? X is 5 or negative 3. So what that tells me is that this point is either, this point has an x coordinate of either 5 or negative 3, okay? Because that's what I got when I worked that all out, 5 or negative 3. Well, I gave you this picture for reference here, so that's 1. This point's to the right. So that point's got to be like 5 comma something, okay? And, all right, because that's 1, 2, 3, 4, 5. 5 is to the right. Why did I get this negative 3, though? Why did I get that? Why did I get 2 answers? Well, okay, think of it like this. Could there be another tangent line that also hits that point? Look at that curve. Does it have the shape to do that? I think so. I mean, my ruler could be, you know, the tangent line to the curve. And yeah, there's another spot, like maybe like right about here. There's another spot where if you found the tangent line at that point, it would also hit this point 1 and 20. That's why you find 2 answers, because there's 2 places this line could actually be. There's 2 tangent lines that, if projected from the curve, will eventually intersect this point 1 and 21. Okay, but I was asking you to find this one. And this one is to the right of that one. So this one over here is negative 3 comma something, but that's not the one that was indicated in the picture. That's not the one that we're looking for whatever reason. This is it, okay? So it says find the y coordinate. So the x coordinate's 5. What would the y coordinate be? Well, again, on the curve, y is negative x squared plus 6x. So that's going to make the y also 5, right? Because that's negative 25 plus 30. That's 5. So my answer, the y coordinate of that point right here needs to be 5. All right. So my final answer I'll put here. If it's on WebAssign, you just type in a number. 5 is it. Okay? All right. So we won't give this one, though. Just that one. Okay? And we'll take the picture at face value. That's what I'd like you to do. Okay. How about one more then? Example 3, my third and last one this time. And I think this is the easiest one. It may not look like that when we first start thinking about what you see here, but it is the easiest one. Which says find the unknown point in the picture below. Okay, so I have again a curve. In fact, it's the same curve as before. All right. And I have an unknown point and a tangent line to the curve at that unknown point. And then some line that's distant from the curve. And it's given an equation. Y is 1 over 8x plus 10. And what this picture seems to be saying is that the tangent line to the curve at this unknown point is perpendicular to this line. Okay? So what's that point then? If this tangent line is perpendicular to that one. You know, these are 90 degrees right there. If that's too small to see, I'm just saying that's a 90 degrees angle. They're perpendicular to each other. Then it's given that this is some other point on that line. So I gave you that, but I mean, part of what I'd like you to be able to do is read a mathematical situation given by a picture or not, and figure out what information is important about it and how to use it. This time I gave you that, and that point is on that line. You can check and see if you want to. If you put negative 8 for x, you will get 9 for y. It's true. But I don't see why that's needed. And here's why. Okay? The premise that we can use to work this one out and find that point is that the slope of this tangent line is actually known already. Okay? The slope is known. Why do I say that? Well, that tangent line is perpendicular to this one. Okay? So that means its slope has to indicate that it's perpendicular. You remember when you learned algebra, perpendicular lines have what kind of relation between their slopes? Their slopes are negative and reciprocal. So if this line is perpendicular to this one, their slopes are negative and reciprocal. So that means that the slope of the tangent line is negative, since that one is given to be positive, and reciprocal 8, okay? Because the tangent line is perpendicular to this one, and that one has a slope of 1 over 8, right? That's the slope of it, 1 over 8. The slope of this tangent line is negative and reciprocal to that. It's negative 8 as opposed to positive 1 over 8. So, okay, slope is negative 8, okay? Now, we'll find this unknown point. So, what was our working premise with that other problem? That you can find the slope of the tangent line by y prime. So, let's see, what's y prime? I had used y prime for this curve in my other example, and it was negative 2x plus 6, all right? So, where's the point where y prime is negative 8? That's what it comes down to, okay? Where on this curve is y prime equal to negative 8, all right? So it's like I want to match these two things up then to find that point. So, okay, let's take negative 2x plus 6. Set it equal to negative 8, all right? Fairly simple algebra from here. Negative 2x, say if I add 6 to both sides, it'll be negative 14. And then if I divide by 2, I'll get 7. So that's the x-coordinate of this point. Right here, it's 7. Okay, what's the y-coordinate? Well, okay, we generally find the y by the equation for the curve if it's known. In fact, the equation of the curve is known to be negative x squared plus 6x. Okay. So let's see. Whoops. So we'll get negative 7 for the y-coordinate. Okay, so negative 49 plus 42, negative 7. So that will be my answer. This time it says find the unknown point. It doesn't say just find the y-coordinate or something like that. The point is x and y. It doesn't specify any further, then there it is. Okay? All right, now I want the process to make sense, though. Okay? Not just that you follow the steps, but the steps seem reasonable to you. So as you look at all of these problems, including this one, then does it make sense that you would equate these things to find that point? Right? Do you see the reason for that? That they tell you the same information, that y prime tells you the slope, and if you know the slope, then you can set them equal to each other to work backwards and find the point. Okay? All of the other questions I've done have similar reasoning to them. Make sure that you can do the math. Right? There's an element of math or algebra in this case involved in it. But also the premise that you use to set it up, that's got to make sense too. All right, so go back and think about that. Make sure you can do the algebra. Make sure the premises make sense and so on. And then ask for help if you need it.